Hello everyone, welcome to my channel Poken Academy. Now in today's video I will discuss a topic of ICSE and CBSE, that is periodic table. Okay, now today I will give the introduction of this periodic table. That is now how this topic comes actually. Now we know that after the so many elements are there in our environment, that it was observed, okay, and discovered so many elements. So after the discovering of so many elements, it was very hard to know their properties, okay, and so we need to classify the elements so that there will be easy to make the difference in the chemical and physical property of the elements, so it will be easier for the chemist. Okay, so they thought actually how to classify the elements. We need to classify. Okay, so so for the classification of the elements, okay, they tried to make a table. Okay, that is called periodic table. Now before that, a scientist named Dobereiner, okay, he arranged three elements as triad. Okay, he arranged three elements as triad. Okay, that their according to their atomic weights. Okay, according to their atomic weights. The name of the scientist is Dobereiner. Okay, and the rule he has given, that is called Dobereiner triad rule. Okay, now he arranged three elements according to their atomic weights, like as that the atomic weight of the middle element in that arrangement, the atomic weight of the middle element is the average of the atomic element of other two elements. Okay, that is called the Dobereiner triad rule. He has seen. Okay, and that is the starting period of the formation of periodic table. So it is started by the Dobereiner in 1870. Okay, in 1870. Okay, now see lithium, sodium, and potassium. He has taken some examples like this triad. So these three are called triad. Okay, what he has observed, that according to the atomic weights, actually he has arranged the atomic weight of lithium is 7. Okay, say it is 7, and for potassium is 39. He has seen that in a triad the atomic weight of first and last element, okay, that means the atomic weight of the middle element will be the arithmetic average of the other two elements. Now what will be the atomic weight of the sodium? It will be arithmetic average of 39 plus 7 by 2. So we'll get 46 by 2 equal 23, and it is correct. It is the atomic weight of sodium. Understood? So this is the triad rule, Dobereiner triad rule. Okay. So before reaching the periodic table, you have to learn these things. What is first? Dobereiner triad rule, and these three are called triads. But what is the default of, and what is the problem of this theory? That it cannot go beyond calcium. That means this rule is not applicable the elements which are after the atomic number or atomic weight calcium. Okay, it can be applicable for elements which are up to calcium but not beyond that. Okay, so that is the defect of this rule. Okay, so that this rule is after that rejected. After that, again in around 1863, one scientist, his name is that Newland. He has made another arrangement that some elements are there if they are arranged into their chemical properties, that, and then he has seen that chemical properties means they are into their atomic weights. If 8 elements are arranged into their atomic weights, increasing order of their atomic weights, then the chemical properties of the first element is similar with the 8th element. Okay, it is similar with the 8th element. Those are all actually the Newland octave rule can be applicable for those elements. Okay, so he has arranged the 8 elements according to their increased number of increasing atomic weight, so that the physical and chemical properties, actually the chemical properties of the first element is similar to the 8th element. Okay, so it is called Newland octave rule. After that, okay, we need to arrange so many elements. So it is a change which is done by the Mendeleev, okay, which is done by the Mendeleev, and he has formed a periodic table which is bearing some vertical columns and horizontal lines, actually horizontal lines, and that table is called periodic table. And there we can arrange so many elements, okay, according to the atomic weights. Okay, so mainly what he has done, he has created a table, he has made a table which consists of some columns, vertical columns, and some horizontal lines. Okay, vertical columns are called the groups and horizontal lines are called periods. Okay, and in mainly periodic table there are 8 vertical columns are there, and it was named as 1 2 3 4 5 6 7 8, and in between the vertical columns, that means groups, there are some subgroups also there. Okay, and total number, if you add the subgroups and again the groups, you will get 15 number of groups in the Mendeleev periodic table. Okay, and there are 7 horizontal lines was there, those are called the periods, and there are 7 periods are there. Okay, so simple, and it has arranged, the elements was arranged according to the atomic weights. Okay, so he has given a theory, rule actually, okay, that is called Mendeleev's periodic law. Mendeleev's periodic law, and that is nothing but the chemical and physical properties of the elements are periodic function of their atomic weights. Okay, this law is given by the Mendeleev, and this law is called Mendeleev's periodic law. And there are 7 group periods are there, that means horizontal lines like this. These horizontal lines in the periodic table is called periods, and there are 7 periods. Okay, these all are called periods, horizontal lines, these all are periods, and 8 vertical columns were there, those are groups, and in every group there are subgroups are there, those are called A and B, like that. 1 2 3 4 5 6 7 8, like this, 8 groups were there and 7 horizontal lines were there. So this is mainly periodic table. Okay, but some defect was there in the Mendeleev periodic table. He was unable to place hydrogen in the proper column. That means in the periodic table they are arranged actually their atomic weights. So those elements which are similar with their atomic weights or similar with their properties, they are placed in a particular group, in a same group. The elements which are having same property, they are placed in a same group. Okay, so lot of elements were placed, but he was unable to place hydrogen properly, and some elements which are rare earth element, that means actinoids and lanthanoids, he was unable to place actinoids and lanthanoids in the periodic table in the proper position. He was unable to give the isotopes in the proper position. So that is the defect of the Mendeleev periodic table. After that, Niels Bohr was formed a new periodic table which is called modern periodic table, and okay, and that is also done by the Moseley in the modern long form periodic table, which is consist of, that means that periodic table is done on the basis of the atomic number, not the atomic weight. So more extended classification that is done on by the Moseley and your Niels Bohr. Okay, so that is on the basis of atomic number, not on the atomic weight. Okay, so that property is called the physical and chemical property of the elements are periodic function of the atomic number. That is modern periodic law. That is the modern periodic law, that physical and chemical properties of the elements are the periodic function of the atomic number, and that periodic table can hold more number of elements. Okay, and that is more extended. In the Mendeleev periodic table we have seen 8 group, and if you join the subgroups also there will be 15. But in the modern periodic table there are 18 groups are there and 7 periods, and more extended classification we have done. That chemists have done the more extended classification. Okay, so in the Mendeleev's periodic table there are 7 periods. Also in the modern periodic table there are 7 periods. But in Mendeleev periodic table there are 8 groups and some subgroups are there. But in modern periodic table total 18 number of groups are there, no subgroup. Okay, and all the elements are properly arranged. Okay, so we have to learn on the that period table. Okay, that period table is more important than this period table. Okay, now there are 18 groups are there, 7 periods, 7 periods and 18 groups in modern long form period table. Okay, so that the number of the groups will be done by 1 2 3 4 18 up to that. Okay, so like that we have to give the number. Now that period table is divided into 4 blocks. Okay, one is S block, another one is T block, another one is P block, and another one is F block. S block consists of 2 groups, group number 1, group number 2. D block consists of group from group number 3 to group number 12. Those are could be called as a D block elements. And from group number 13 to 18, group number 13 to 18 will be called as P block elements. Okay, and some elements were there which cannot be placed in the D block. Okay, in the D block, and their properties are very different from the D block elements, and those elements are placed in the bottom of the period table as F block elements, and they are actually should be placed in 6th period and 7th period, but they are not placed because these elements have not same property with the F block elements. Actually the D block elements are transition elements, but some transition elements are there which having not property same property with the D block, so we have to place in another OS in the bottom of the period table, that is called F block elements, and that will be 6th and 7th period. Okay, and those are called lanthanoids and actinoids. Those elements which are present in the group number 6 of the period table, those are called lanthanoids, and which are present in group number 7 are called actinoids. Okay, just I am giving the description of this period table first. After the next video I will discuss thoroughly. Okay, in first period, in the first group, the elements which are present in the first group are called alkali metals. Okay, these are called alkali metals. The elements which are present in the first group are alkali metals. In second group, alkaline earth metals. Okay, alkaline earth metals. The elements which are present in group number 3 to 12 are transition elements. Transition elements. Elements which are present in group number 6, period number 6, separately from the transition element are called lanthanoids, and these are called actinoids, which are present in group period number 7. Elements which are present in group number 8. Okay, there are 18 groups. Group number 1 alkali metals, group number 2 alkaline earth metals, group number 18 noble gases. Okay, they are called noble gases. Group number 70 elements are called halogens. Group number 70 elements are called halogens. Group number 16 elements are called chalcogens. Okay, group number 16 elements are called chalcogens. Group number 15 elements are called nictinogens. Okay, nictinogens. Group number 14 elements are called family of carbon, and group number 13 elements are called family of boron, because the first element of group number 13 is boron and group number 14 is carbon. So it is the family of boron, it is the family of carbon. So this is total description of the period table, modern long form period table, and we have to learn properly every element. We have to know the atomic number also, and we can discuss the periodic properties, that means chemical and physical properties, how they are rearranged, how that can be changed, can be easily done by this period table. So this is very important. So next year I will discuss about the properties of the period table, that means periodic properties. Okay, how they will vary for each of the elements, that one we will discuss. And so today's video is up to this. Next day we will make another video about the properties of the period table. Okay, so thank you for today's video. So if you have not subscribed my channel, then do subscribe, so I can make the other videos. Okay, thank you.